So welcome to our next group. We have Ronnie Hammerslag, Gerald Whittle, Frank Futon, Philip Bangarter, Renata Cardoza, Mirko Notte, and our two moderators, me and Virginia David. So if you could say hello to the panel, I will introduce you now. It's being moderated by Frank. So Frank, I will turn it over to you and we'll adjust your slides as needed. But thank you for being with us today.
Okay, thank you very much, Justin. So greetings and welcome to this plenary talk. My name is Frank Futon. I'm the chair of the Department of Earth Sciences here at Brock University, and I'm the moderator. The topic that we'll be exploring for the next 50 minutes is holistic approaches, integrated strategic planning, and sustainable resource development. And we'll provide answers to the obvious question of what is a holistic approach to resource development and how does it differ from conventional approaches and what are the benefits? So I study Mars, so this is far outside my expertise, but I'm fortunate enough to be joined by 4 experts in this topic, and I'll ask them to briefly introduce themselves. Gerald, do you want to take it away?
Thanks. I'm Gerald Whittle. I'm the CEO of Whittle Consulting, and I'll talk about our process a little later. But for 20 odd years been doing what we call integrated strategic planning. My background is I trained to be an accountant. I was a very introverted teenager, but I've been doing not accounting, but financial management in a number of industries. I spent some time overseas when I was in my late 20s. I went to the Middle East, learned a lot about the world and learned a lot about myself, and worked in Europe, finance director of an airline, and now in strategic mine planning on an integrated basis, which I'll explain later.
Okay, thank you. Philip?
Yes, hello everybody. My name's Philip Bangarter. I'm originally a process engineer, but spent a good deal of my career, which is now spans 40 years, in technology commercialization within the mining industry. And in about 2004, made the transition into sustainability while I was at a major engineering consultancy. And I've been an independent consultant for the past 5 or 6 years, and my primary client is Whittle Consulting, where I provide the assistance in our carbon modeling and other sustainability modeling. And I'll go into that a little bit more during this session. Thanks, Frank.
Okay, and joining us from Sweden is Ronnie. Go ahead.
Yes, my name is Ronnie Hammerslag, and I'm the CEO of Nordic Iron Ore, a startup mining operation in Sweden, in the northern part of Europe. I recently come from Boliden, a bigger mining company, to join this green startup in the green iron ore and green steel that I will talk more about later on today.
Okay, and last but not least, Mirko Notte from Bulgaria.
Good morning, everyone. Thanks, Frank. My name is Mirko Notte. I'm the VP Operational Excellence and Technical Services for Dundee Precious Metals. As Frank said, based in Bulgaria, we have 2 operating mines here in Bulgaria, an open pit and underground mine, as well as a couple of development projects next door in Serbia, as well as in Ecuador. I look forward to being part of this panel and discussing a few things around the holistic approach to integrated planning for sustainable resource development. Thanks.
Okay, thank you very much for all those introductions. The format for the panel will consist of approximately 8-minute long presentations by each panel member. You'll notice that 2 of them talk about it in principle and 2 of them are essentially case studies. Following that, we'll be happy to take questions from the audience, and hopefully there'll be some time for concluding discussion. To ensure that we sort of stay on time, I'll raise my hand after 8 minutes, and without further ado, I'll ask Gerald to take it away.
So a brief introduction to what we call integrated strategic planning, specifically for the mining industry. Just the history of the Whittle organization. Any mining engineer or geologist will have heard of the Whittle software. My father, Jeff Whittle, was prolific in the 1980s in writing optimization software for mining. And I've got a list here of the software he developed during the 1980s and 1990s. He ran a family business basically out of my old bedroom at home in North Balwyn, Melbourne, initially, and sold that to Gemcom in 2001, and then has been since acquired by Dassault Systèmes, the Geovia brand. So the Whittle pit optimization software and some scheduling tools are out there. Since 1999, when I returned from Europe to Australia, I knew nothing about mining, but I found a very interesting business planning in the mining industry has so many opportunities in it and complexities, great challenges. We started Whittle Consulting, and my father, who's in his 90s now, has done some of his best work in terms of software in the last 20 years or so. And we've developed a combination of software and methodologies for what we call now integrated strategic planning. So the approach is to look at the whole system. And a mine is a very complex system. We have a lot of information on a mine. We have geological models, gigabytes of information about what the resource is. We develop mine designs in terms of open pit mines and underground mines, depending on what's appropriate. We have detailed mine scheduling tools, Deswick, Vulcan, and so forth, to plan out a life of mine plan in great detail, equipment movements, personnel assignments, etc. We have very sophisticated models of the plant and the flow sheet, depending on what the flow sheet is, looking at the recoveries, the throughputs, all the characteristics of how the ore behaves when it's put through the system. Logistics model, potentially with Monte Carlo simulation of the movement of the trains on the rail loops, etc. A commercial model, probably in a spreadsheet, and a financial model in a financial system. So even in a pre-feasibility study, let alone an existing operation, there is lots of data, but it's in 5 or 6 different systems run by 5 or 6 different parts of the organization, what we call organizational silos. And we're all familiar in any organization how people love to divide themselves into separate groups of specialists, and they keep to themselves very closely, and they get on very well with each other and not very well with the other groups. So our approach is to just ride across those silos, bring those silos together, integrate them, and we build a single model of the whole system. And that takes some sophisticated software, which we have. So we end up with a single model of the whole system, from the gigabytes of block model information through all the recoveries, the capacities, the ore losses, the dilutions, et cetera, through to the financial model in one model. We use a technique called activity-based costing, which is a method for modeling the way the costs behave that's more accurate than most mining companies use. Activities are things like drilling, blasting, loading, hauling, crushing, grinding, floating or leaching, or smelting, depends on your flow sheet. And we try and identify how the different blocks of material in the ground behave when they go through the system. So we're not just interested in the tons and the metal grade, which drives the revenue, obviously. We're interested in the depth, the density, the distance, the fragmentation characteristics, the crusher work index, the bond work index, the abrasivity, the density in the slurry, et cetera, and gives us much more accurate financial modeling of the consequence of mining and processing different parts of the ore body. So we end up with a dollar version of the ore body in terms of, we have a geological version of the ore body. Now we have a dollar version of the ore body. We can see for any block what the revenue would be from it, potentially, and what the cost of mining, processing, and producing it would be. So we have a spatial economic model of the ore body. We can see where the cash margins are. And so we look at the ore body on a dollar basis, and we have this old saying, it's not a copper mine or an iron ore mine, it's a money mine. We're mining the dollars. And from an economic perspective, that's correct. At that point, you're halfway, because the next step is to understand the system. Theory of constraints tells us that any system has constraints or bottlenecks in it. And every system has a primary bottleneck, the part of the system that most limits the performance of the whole system. And in a complex mining situation, it's not always obvious where that is. And also it tends to move over the life of the mine because the ore body is changing, stripping ratios, densities, recoveries, etc. So we look at the whole as a system, an economic system. I mean, it is a physical system as well, but we look at it on a net value, that's the profit margin per bottleneck unit. And therefore, we develop a life of mine plan with pits, phases, underground, mine schedules, cut-off policies, blending, stockpiling, processing, calibration, changing the grind size from time to time, changing the product mix and specification logistics, and scaling the system, because we determine where the bottlenecks are by design to maximize the flow of cash through the system. So the primary objective of this approach is to increase the early cash flow, move the cash flow profile, net cash, over the life of the mine, and this is years across the bottom, to bring the cash flow forward. And you don't need an MBA in finance to know that generating cash more rapidly gives you less risk, a better return on investment, etc., etc. Net present value uplifts between 5 and 35% or substantially more from exactly the same resources, exactly the same design. Now, back in the 2000s, the first decade of Whittle Consulting, the biggest problem in mining was that people were spending billions of dollars of capital and not getting adequate returns. So this was highly relevant, making mines economic. What happened, it's probably 4 or 5 years ago, we recognized, look, there's more to it than just economics. You've got to have an economic mine, otherwise there won't be a mine. But the issue of expanding the breadth of criteria, not just looking for things that make money, but things that create other benefits. So the end of where we're up to now is integrated strategic planning is a concept of long-term planning. It requires cross-functional collaboration. We need to get the silos, the geologists, the mining engineers, the processing engineers, the metallurgists, the commercial people, the finance people to work together. And there is a massive opportunity from harnessing their collective skills and perspectives, but building a framework, and this is the framework to help that get the best result for the system. We need to consider all parts of the value chain. We know for any system that you can't optimize the individual components, put those together and expect the system to be optimal. It doesn't work that way in any situation. And this is approaching that issue. We need to consider all time periods. That's what's different in mining compared to manufacturing and transportation. And I've worked in those industries. You need a 20 or a 30 or a 40-year plan. Whatever you mine this year will be gone. You can't do the same thing next year. And whatever you mine this year sets the surface in the ore body and therefore your options for what you do next year and the year after and the year after. Now, your 30-year plan may change 30 times over 30 years. But at any point of time, you need a plan from where you are today to where this thing will finish, rehabilitation and everything else. And that complicates the planning and the mathematics and the modeling immensely. But what we've done in the last few years, and I'm kicking myself we didn't do this like 10 or 15 years ago, but we've started expanding it because there's more important things than just looking after the shareholders, which are important, but looking after the government, employees and the community. And so I'm going to hand over to, back to Frank, but over to Philip, my colleague, to talk about more about how these dimensions and the environment, of course, are coming into this modelling. So very sophisticated modelling, primarily operational and financial, but for a broader range of objectives than just making money.
Okay, thank you very much. Philip, go ahead.
Thank you, Gerald. So just to continue the theme, the traditional NPV dominated assessment has been, I wouldn't say superseded, but has been added to by looking at multi-criteria evaluations as well. And I'm going to talk mostly about carbon today, but it applies to all of the other things that Gerald just mentioned around water tailings, employment in particular, but anything that that is the focus of stakeholders, not just the economics. And I like to start with this slide, this material from Visual Capitalist, where it compares the difference between two different vehicles. And as we do an energy transition, our vehicles are going to change from gasoline and diesel through to electricity. And we have to understand our what we call a carbon rucksack, which is the embodied carbon dioxide that's contained within the metals that are used to make up everyday things such as motor cars or telephones. And each of those metals has a particular carbon content. So it's incumbent upon the mining companies and the people that help them to understand what their contribution of carbon is into that motor car, or indeed other things. There's an example there. It gives you the tons of CO2 equivalent per ton of aluminium, steel, copper. And those are the major components of any motor vehicle. I've got another slide, the same story here around wind turbines, the other thing that we need for our energy transition. And you can see in these figures that copper accounts for about 12 tons in this 3 megawatt turbine. Steel is 620 tons. Steel is the biggest metal of all, and the one where so much of the emphasis must be to decarbonize steel. And you can see much of the other materials there. It's especially true in electric vehicle manufacture, but those end users of our products are starting to question and to demand knowledge of our carbon rucksack, our carbon footprint, the embodied carbon within those metals. So the mining companies need to know what that is, and need to know what it's going to be in the future. And Gerald alluded to the fact that we have 10, 20 or 30-year plans, and the carbon dioxide footprint of your product changes year by year, and it's incumbent upon us to understand what that is. So at Whittle Consulting, for the last 2 years or so, we've been adding the carbon content to the calculations so that our clients can understand how that CO2 changes over time periods. And I think Mirko and Ronna are going to explain a little bit about how we did it for their organizations. Just as a reminder, Scope 1, the emissions created by yourself on your operations. Scope 2 is emissions from the energy that, usually electricity, that's produced off-site but used on-site. Scope 3, upstream, is the rucksack contained in in your supply chain. Chemicals, explosives, grinding media, and so on. Downstream, in the Whittle Consulting context, the downstream is particularly about transport from a mining operation to the mining company's customer. But in a more general sense, it also includes the emissions produced by your customer and indeed your customer's customer. So to be helpful in choosing how to plan or choosing a scenario that you might and in what order you might mine your ore body, we now not only have those economic indicators such as net present value, we also have carbon and other things. So these two charts on the left-hand side, we can see this particular project, which happens to be the one that we did for Mirko and Dundee. The left-hand chart is showing that as they might choose any one of those scenarios, you can see on that chart the effect of increasing in PV gives you, in fact, an increase in your scopes 1, 2, 3 inventories of CO2. But the right-hand chart gives you better news in that this is now an intensity. So I talked about the rucksack, the footprint. We can also call it a carbon intensity. And in this case, CO2 equivalent per gold equivalent ounce. You can see that trend is downwards. So as we optimize and move forward in the planning, the intensity of each ounce of gold has dropped in this case. And this can be true of any operation. So what I'd like to explain here is why it is that intensities can decrease. So let's start with an unoptimized mine schedule. This would be a very typical starting point for us. The carbon intensity in an existing operation or the plan for a project is fixed by the nature of the ore body. So how deep it is and what the relative grades and other geotechnical and spatial characteristics of that ore body. If you optimize it, then optimization, as Gerald partially explained, favors shallower, closer, higher grade, lower strip ratios, and softer material. If you optimize, it favors all of those things. Your CO2 intensity will drop in comparison to an unoptimized schedule. So this is part of the good news of optimization. Then you have potentially a stroke of luck, and your unit costs for processing decrease, or the market gives you a higher metal price, for instance. This actually has an effect of increasing the carbon intensity. It's because it favors exploitation of more marginal material within the existing pit shells that you've designed. So more marginal material comes into the schedule, and that newest material that's you've now decided to process is harder or further away or deeper. Therefore, the CO intensity goes up. Very similarly, you might have an improvement in your mining costs, and now cutoffs are lowered, and the life of mine is increased, and the pit shapes are expanded. And this also has the effect of increasing CO2 intensity. Finally, a bit of good news. If you get process efficiencies and so on, this favors high throughputs for the same unit of energy. This has the effect of decreasing carbon intensity. So the carbon intensity, unlike manufacturing or indeed flying aircraft all over the world, it's not possible to predict a constant CO2 intensity. As the ore body changes, it's a very non-linear thing. As it changes your carbon intensity. So there are some decisions to be made around all of those things: how to schedule your mine, and how to choose equipment, and so on. And unless you're going to decarbonize, then that CO2 will vary. And these days, many mines, and I think Ronna is going to talk about that, they are decarbonizing their energy inputs. So you can electrify your fleet. You can use in-pit crushing and conveying to move some of the diesel consumption from mine trucking onto electrically driven conveyors. You could swap over to electrification via renewables, not just take the electricity from the grid. And you can make changes to your the way you process or mine, such as these things here. You can alter your grind size and adopt things like coarse particle flotation. You change your tailings volumes, and you might adopt dry stacking tailings. All of these things will affect your energy consumptions, and therefore, thank you, Frank, and will therefore adjust the mine schedule. We call them first, second, and third order effects. So the first order effect is those cost and throughput effects, which is generally easily done. Second order effects are those that affect the cutoff and the pit shapes. So as you change all of those things in a material way, it will need re-optimization, because you'll change the nature of the costs involved. And then the third order effects are those around water and carbon. So so just to quickly summarize and pass it back to Frank, we've taken the original Whittle Consulting approach, which was dominated by NPV, and now added those third order effects of carbon in this case, but as well with water. Frank, back to you.
Thank you very much, Philip. And we'll pass it over to Ronnie now, so he can tell us how this works on his mine in Sweden.
So what we have been doing in our case is that we have, together with Whittle Consulting, worked on the electrification, the fleet. One of the examples Philip was mentioning, that we went through our mobile fleet, and the original plan was to have a diesel fleet, but then we made over to an electrical one, and then we could see that by switching over from a diesel fleet to an electrical fleet, we could reduce the carbon emission per tons quite severely, up to 95% closely. So what we did basically, to jump a little bit in the presentation, we went through the diesel fleet. So you can see the darker line on the top was the original plan with the diesel fleet, and then together with Whittle we worked to do the optimization to check what would the impact be if we go with an electrical fleet. So the scope was very severely reduced from the down to the yellow line there if we then count on scope 1 and 2. Of course, if we then include, as you can see on the right hand side, also the scope 3, the downstream transportation, is very much dependent on the vessel transportation from the Oxelösunds port down to Europe. The vessels are still driven by sea diesels, but once they are electrical or driven by hydrogen, we can even get a lower emission from the downstream fleet as well. So we also have that on the next page, Frank. Then you can see the upper more green-blue bars are the impact from the vessel transportation. So I mean, you can see really how that impacts our emissions, and of course we are working with different shipment companies to see what their plans are and what they can do to reduce that emission. But we are doing our utmost in our fleet, and in Sweden we are quite lucky with having a lot of green electricity taken from the grid, so we will have an almost electrified complete mine. But that also, when we do the comparison, the carbon dioxide equivalents per ton of concentrate, we get a very low intention, down to a few percentage of carbon on the concentrates. And we're also working here to see where we stand out in the global scale, and we are pretty good off. So that actually means that we are saying that we can produce a green iron ore for the green steel market. So you can go to the next slide. There's a very high demand right now ongoing in Europe for cutting out the CO2 or emissions. I mean, the environmental concerns and all the regulations. There is a premium customer pressure to acquire green steel for green production of windmills and cars, and there's actually a willingness to pay extra money for get hold of that green steel. And we see in the foreseeable future that there's actually a lack of these concentrates that are suitable for the green steel production. So in the next 10 years or so, there's a big investment going to happen in the mining industry to get concentrate suitable for direct reduction processes and the green steel production, moving from the blast furnaces over to new technology. And on the next slide, we can see that today there are roughly 3% of the global production of iron ore products that are suitable for this green steel and the direct reduction process with the high grade. We're going to provide from Nordic iron ore mines in Sweden. We are close to 69% on average, so we're really on the top and far above the 66% that are required for the direct reduction processes. And even if you put this into a blast furnace, you will have less carbon emission because we have higher iron content from the beginning. So regardless of process, we're going to reduce the carbon emission based on our iron ore. In the global arena, roughly 9% of all the carbon emission globally is coming from the steel value chain. So I mean, the world really needs green iron ore for the green steel making for the future. Thank you.
This is Dundee. So yeah, I guess just a little bit of context for today's. At Dundee, we do believe sort of we as a mining company are there to generate net positive impact, and we've embarked on this journey, and it is indeed a journey. I can say that for sure, to take on the 6 capitals reporting framework now, and then that hopefully will give us us and the rest of the industry eventually a way to capture the overall impact that we as a company and we as an industry are making along those 6 capitals, right? And hopefully become and no longer be known as an extractive industry or perceived as an extractive industry, but rather as a development industry or something along those lines, right? So we do believe that, and climate change or the targets around climate change or carbon emissions, that they're obviously just one aspect of it, but we're focusing on that today. So in line with that, Dundee, earlier this year, we once again, it was a process. We worked through a couple of things, couple of sessions, and came up with what are the Dundee climate change targets. And the two key targets we've set for ourselves is to reduce our absolute, not relative, but absolute scope 1 and 2 greenhouse gas emissions by almost 40% by 2035, and be at net zero by 2050. And then spend the next couple of years to develop our scope 3 emission targets. That's a little bit more complex, so we need a little bit more time on that. So those are the targets we set ourselves now. We've also identified a few activities that'll be key over the next 18 to 24 months in order to ensure that these climate considerations are incorporated into our business model, into our operating model, etc. And in summary, those 5 can be boiled down to, it's always starting with governance, accountability. We need to integrate the climate metrics and targets. Sometimes we need to, in certain areas, we need to define the metrics and set them up. Then once you've got the metrics and targets, how do they drive capital allocation decisions? And that needs to be integrated there, right? It's not purely an NPV question or a safety question. It needs to be incorporated there. And to do that, I guess, objectively, in all likelihood, we'll need to develop, if not externally enforced, at least an internal carbon price to make those decisions a little bit more objective. And then overall, we need to start capturing or incorporating any climate risks within our overall Dundee enterprise risk management tool. So that's just a bit of context in terms of Dundee, but for today's discussion, I think there's a couple of key things. As Frank mentioned, I want to give you a practical example of how we applied integrated strategic mine planning with the help of Whittle Consulting, looking at that, how we capture carbon in that, or the carbon emissions in that strategic mine plan exercise of ours. Share some of the findings and insights that were generated during the process, as well as an output, and a couple of points, not an exhaustive list, but just a couple of points where to from here. So the example I'll discuss relates specifically to 2 of these activities, which you'll probably be able to link up to. It's around starting to integrate climate metrics and targets into our operational activities. In this case, long-term planning, mine planning. And then you can see that we didn't quite get there yet, but that's the obvious next steps. All right, now that you get this output, all right, what do you do with it? How do we drive capital allocation, life of mine plans, etc.? How do we drive those? How does climate or the output of your carbon footprint drive those decisions? Anyway, so hopefully you'll recognize those 2 in the example that I give, and this is a real life example, if you want to call it that. So I'm Gerald and yeah, thanks for running us through the whole process, and Philip, thanks for taking us through the carbon aspect there as well. So I don't need to spend any time on what Whittle does and what the integrated optimization process looks like. And so we do this on an annual basis, not so much necessarily the big strategic exercise, but the life of mine for our operations gets updated at least once a year. And in 2021, we engaged Whittle to do a slightly bigger strategic optimization study. And as Gerald said, this is cross-functional and involves pretty much everyone. And for the first time, this time around, we involved some of our environmental engineers as well. And to Gerald's point earlier, they were quite surprised in terms of why do we need this information, and what are we going to do with it? And like Gerald said, we all have our silos and where we feel quite comfortable, and suddenly somebody peeks over into your silo or asks you some information there. You need to be given some context. Anyways, that's part of our role, breaking down those silos and looking at this holistically. Anyways, so we looked at it, and it's really so Gerald used the term activity-based costing, but what it really boils down to here, it's really activity-based emissions, right? So as any modeling exercise, your output's really only as good as your input assumptions. So we spend a lot of time and effort on making sure those assumptions are valid, as valid as we can get them. And for the first time this time around, last year, we included these carbon emissions assumptions for each of or most of the activities. And then, so once you have that in there, and as was said earlier, so you've got your trucking distances, your ore hardness, which is sort of equivalent to the power you need to grind it, etc. And then as an output, you have your life of mine plan, and beyond the multiple tens of scenarios that we sort of get out as an output from the Whittle software, which the normal items you look at is your life of mine plan, your production profile, your cash flow, how that equates to NPV. But for the first time, this time around, we actually said, well, what are the carbon emissions, scope 1, 2, and 3, for each of these scenarios? And you basically have your emissions over the life of mine. And these are shown here as just a couple of examples of certain scenarios that measure that. And maybe a key takeaway here is, as you can see there, more than 50% of our total emissions are scope 3. And you'll see shortly why that's sort of important to understand. So that was sort of a first step, and it took a bit of time to get those, like I said, those input assumptions are important, understanding of it, and then actually interpreting the output and what do we do with this output. So a couple of, let's say, takeaways on that was, for us, and I'm talking absolute here, so what Philip showed, and he used a couple of examples of our output there, was, yes, the gold equivalent, or sorry, the word just escaped me, but the emissions per ounce of gold, or a gold equivalent ounce, was basically, it became less intensive, less carbon intensive, as sort of the value of the operations, or as the NPV went up. We wanted to take a look at what I'm showing here are the absolute value. So something to take note here is that the scope 1 and 2 emissions are fairly constant over the different scenarios, and to a certain extent that's not too surprising. Chelopech is a fairly, well, a couple of things to note on Chelopech. Is fairly homogeneous ore body, large ore body. It's also a fairly balanced system with a cap on throughput, a permitting cap. So we didn't, most scenarios were sort of capped on throughput, call it artificially. So hence, not too much of a surprise that your scope 1 and 2 emissions, which are really your emissions on site and the power you use to grind the material, didn't vary too much between the different scenarios. However, the scope 3 emissions, they vary quite a lot. And to my previous slide, they are the biggest one. So varying scope 3 emissions means your total emissions, if you consider all of them, vary a lot. A couple of things to note there, and this is mostly because of this is downstream transport, downstream processing. And maybe a caveat here, or footnote to note here, is incorporating the scope 3 emissions is challenging. I mean, scope 1 and 2, not as simple, but scope 3 adds another level of complexity, because some of it's about data availability, understanding the downstream processing, etc. So anyways, these were the outputs. So you might ask, well, what did we do with this? Did it drive any decisions? And the short and honest answer is not so much this time around, or not so much yet, but a lot of lessons were learned in terms of what are the types of considerations we need to start making. And that's where I mentioned, well, maybe you need to add a carbon price. So the way Gerald explained it, you look at your money mine, so you see every block of ore, the net present value, or the NSR value of each block, and that's only looking at the financial view. So how do you incorporate the carbon view into that? Well, the one way to do that fairly objectively would be to have a carbon price, right? So anyways, these are the types of discussions we will need to get into for the next round of this. But And then that brings me, I guess, to my concluding slide. Where to from here, right? So we at Dundee, we know it's not a matter of if this needs to be incorporated. It's a matter of when, and I think the sooner the better. And we really want to be pushing this along in terms of bringing these metrics. And I know carbon's merely one of the sustainability metrics, but that's a topic for tonight. We also know it's a journey. A lot of challenges remain, both within the industry and globally. They're on reporting standards, carbon pricing. How does that incentivize decisions within the industry, within the value chain, etc.? So many things still to cover, but we got to start somewhere. That's not an excuse to do nothing by saying, well, we don't know. It's got to start somewhere. And I think a key thing here, and maybe that brings us back to the topic of today's panel, is it needs a holistic approach. I spoke about the silos within an organization, so holistically within that organization, from all fronts: mine planning, metallurgical, financial, environmental, etc. But also within the value chain. As you can see, it's the scope 3 emissions that are the biggest emissions. So, and you're not going to do much about that in all likelihood. You're going to struggle to do much about that unless you've got your upstream or downstream partners, stakeholders, customers, suppliers engaged in these conversations. And to be honest, over the last 6 months, we've had 2 big commercial discussions that we would not have had 2 years ago, that wouldn't have been a business opportunity if carbon emissions, scope 3 emissions, both for them and for us, wasn't part of our targets to start reducing them. So that just gives you a little bit of an idea of what we did as a single exercise here, but that's really only one piece of the puzzle. There's many other areas we need to be looking at, but this was quite an interesting one and does touch on that holistic integrated approach and how that relates to sustainable resource development. So thanks.
Okay, thank you very much, Mirko. Very interesting stuff. Now, we're also joined here by Renata Cardoso. She's the Vice President of Sustainability and Low Carbon at Electra Battery Materials Corporation. Electra is an important player in the process of building electrical vehicle supply chain in North America, with a refinery in Ontario and a mine in Idaho in the United States. And I'm going to ask her to comment on what she's heard in the next couple of minutes. Go ahead, Renata.
Hi, everybody. It's a great pleasure to be here. Quick context, as Frank just said, I'm with Electra 6 months now, and we have a refinery in Ontario for cobalt sulfate, which is a very important material for batteries for electric vehicles. But we are also starting a demo plant on recycling batteries in this refinery. So this is one important thing that I would like to bring, for us to really integrate the business plan with our ESG strategy. It's so important to take into account the circularity, right? The end use and how you can really recycle your materials through the value chain. But just as we don't have much time here, I'd like to just piggyback Mirko's comments. And everybody else, I think today we saw a lot of presentations on that are confirming that we do have the tools, we do have the methodologies, we do have the standards out there that will help us do this integration between the strategic planning of the companies, the business planning, and all the ESG commitments that we are really declaring, and also considering not only the low carbon piece. This is also my background, low carbon, but now I have an oversight over everything else that needs to be balanced when we are discussing the business strategy as well, right? The social side of the equation in the ESG framework is always critical for anyone in this mining ecosystem, but also thinking of, we have the tools, we have the methodologies. What is missing? And Mirko started by saying, is it easy to do this integration within the other parts of the organization? It's never easy, it's never easy because we are being disruptors. We are trying to change the way things have ever been done. And it's never going to be simple. So how do we do that? We really need to have leadership engagement with all the goals that we announce, because leadership will be driving that. And we do need to get the supply chain on board, because otherwise it's going to be very difficult to move ahead and to advance. You know, and of course, carbon pricing. This is a major thing, because it's going to make the difference in terms of when you look at the NPVs, not necessarily the low carbon solutions will be NPV positive. Not now, but the companies have to ask themselves, how do I want to see myself in the future? You know, because carbon pricing is here and is growing in terms of importance, and it's not going to be only about carbon as well. We need to balance all the other aspects and impacts that we have already. Thank you.
Okay, thank you very much. Justin, I think we're pretty much out of time, correct?
Yes, we are currently looking to transition to the next session, but absolutely wonderful information. I mean, I'm constantly amazed by the variety that we have available with incredible presentation skills as well. So thank you everyone for doing that.
Okay, well,
transitioning now. Go ahead, Frank.
I was just going to thank my panelists, and I was going to thank you and Virginia behind the scenes. And one final thing that I wanted to mention, because this forum is about young people and relevance to young people, and clearly for an industry to proceed in a sustainable manner will be very important to the young people as they're looking for careers where they can make a positive difference to the world. And I think on that note, I would like to thank you all and say goodbye.